So in order to solve this problem, first of all, we notice that this is a linear system. With 4 unknowns and 3 equations. Okay, so let us use the elementary operations on the augmented matrix. So we are going to use the augmented matrix. So basically what we're doing is the raw elementary what? Operations. Okay, great. So first, what is the augmented matrix? So we have the first equation is x1 plus 2x2 plus x3 minus x4. So we have 1, 2, 1, and minus 1. The non-homogeneous term is b. The second equation is 2x1 plus 4x2 minus 8x4. So we have 2 coefficient of x1, 4 coefficient of x2. There is no x3, therefore is 0. x4 has minus 8, and the non-homogeneous term is minus 1. And finally, the last equation, there is no x1, 0, the coefficient. There is no x2, 0. And x3, 1, the coefficient. x3, x4 is 3, and the non-homogeneous term is 1. Okay, so I put the bar, the vertical bar, so only to separate between the coefficient matrix and the non-homogeneous term. Okay, so next what we are going to do is use elementary operations. So the first one, so let us get rid of the 2 and the 4 using the 1. I'm sorry, not the 2 and 4, the 2 using the 1. Okay, the first element there. So what we are going to do is R2 minus 2 R1. Okay, so we're going to take the second row minus 2 times the first row. So we get 1, 2, 1 minus 1 b, and then 2 minus 2, 0, 4 minus 4, 0, 0 minus 2, because it's minus 2 times 1, minus 2, and then minus 8 plus 2, minus 6, and then we have minus 1, minus 2b, minus 1, minus 2b. Okay? And then we have 0, 0, 1, 3, and 1. Okay? So again, by the way, just a simple comment, I could have done an exchange between row 2 and row 3. I could have done that because I have already the 0 zeros, okay? The 0 zeros, okay? Anyway, so now let me divide, let me exchange, because I have the 1 here, okay, the leading term. Let me exchange row 3 with row 2, huh? So we go row 3 into row 2, okay? So we'll get 1, 2, 1 minus 1 b, 0, 0, 1, 3, 1, 0, 0 minus 2 minus 6, and minus 1 minus 2b. Okay, so now we are almost there in terms of row echelon form, except that we have this one to get rid of it, because the leading coefficient is 1 and under it should be 0 to have the row echelon form. So let's do it, and this will give us, so we're gonna do R3 plus 2 R2. Okay, so we keep 1, 2, 1 minus 1 b, 0, 0, 1, 3, 1, and then 0, 0. Minus 2 plus 2, 0. Minus 6 plus 6, 0. And then minus 1 minus 2b plus 2. Minus 1 minus 2b plus 2 times 1. Okay? So as you can see, now this matrix is in the echelon form. For sure, we got our echelon form matrix. Okay, echelon form. Row echelon form, sorry. Row echelon form. We got it. So the first number, non-zero number, is 1 on the coefficient matrix, of course, It's 1. The leading term is 1, and under it are the zeros. So this is the row echelon form. The question becomes now, is it consistent or inconsistent? So what do? You look at the bottom part where you have the rows are all equal to 0. So what do we have here? Okay, if this number, which is, okay, so that's minus 1 plus 2, that's 1, so it's 1 minus 2b. If 1 minus 2b is not equal to 0, then the system is inconsistent. So the system is consistent. So to answer now the question, the system is consistent if, and only if, 1 minus 2b equals 0 or b equal 1/2. So if b is equal to 1/2, the system is consistent. So now what is the equation? So let me write down the matrix. So it's gonna be 1, 2, 1 minus 1, and b is equal to 1/2. 0, 0, 1, 3, 1, and then 0, 0, 0, 0. Okay? So now we need to solve it. Okay? So now we need to solve it. So first of all, how many non-zero rows do we have? We have 2. So what's going to happen to us is that 2 unknowns will be free to take any value. These are your parameters. And 2 will be determined. Which ones will be free and which one will be determined? You look at the leading coefficients. The leading coefficients will force that unknown to be known, of course, as a function of the other ones. So in this case, very important. So the first leading coefficient is in front of x1. Remember, this is for x1, x2, x3, and x4. So in fact, x1 and x3 will be determined as functions of x2 and x4. Okay, so number one, the system will have infinitely many solutions, and x2 and x4 will be your parameters. So here, let's finish the job. So we say, I could have done the reduced row echelon form, okay, but the system is very simple. So here, let me write the new system, the equivalent system, x1 plus 2x2 x3 minus x4 equal 1/2, and x3 plus 3x4 equals 1. Okay, so now we put x2 equals t and x4 equals s. Following the discussion, I just put here in red. Okay, so now what is x3? Okay, x3 is going to be 1 minus 3x4 from the second equation. Okay, and what is x1? x1 will be minus 2x2 minus x3 plus x4, okay, plus 1/2. Okay, so we will get that this is equal to minus 2t minus 1 minus 3s plus s plus 1/2, which gives me minus 2t plus 3s minus 1 plus 3s plus s, 4s, and then minus 1 by that, minus 1/2. So the general solution will be the general solution. So now we go and we put the general solution. The general solution. In other words, the one that describes all the solutions to the system is, so x1 is going to be minus 2t plus 4s minus 1/2. x2 equals to t, comma, x3 equals to 1 minus 3s, and x4 equals to s. Thank you.